I read that our vascular age can be older or younger than our biological age. That sounds important.
It is. And it's a great example for today's topic, simple linear regression.
So regression helps us see if there's a link between the two.
Exactly. And even better, it lets us predict vascular age from biological age. That's what we'll explore now. Let's look at the following example. For 10 individuals, both their biological age and their vascular age have been recorded. Here you can see the results table. We are interested in two key questions. Is there a linear relationship between these two variables? And if such a relationship exists, how can vascular age be estimated from biological age? To address the first question, whether a relationship exists, we will begin by creating a scatter plot. In a scatter plot, each pair of values is represented as a point in a coordinate system. Here is the cluster of points corresponding to these data. You can easily identify all 10 individuals in the scatter plot. We can see that as biological age increases, vascular age also rises, as expected. This indicates a positive relationship between the two variables. The next step is to examine whether this relationship is linear. Using statistical software, we calculate Pearson's correlation coefficient. For these data, R is 0.756, which suggests a moderate linear association. This now allows us to perform a linear regression. We now want to fit a straight line through the scatter of points. Let's first consider the general case. We have a coordinate system with the independent variable x plotted along the x-axis and the dependent variable y along the y-axis. To draw a straight line in this coordinate system, we need two pieces of information to define it uniquely. First, the point where the line intersects the y-axis, known as the intercept, denoted by beta 0. Second, the slope of the line denoted by beta 1, which determines its inclination. The slope can be interpreted as follows. If x increases by 1 unit, y increases on average by beta 1 units. We will return to this interpretation later. With these two parameters, we can write the equation of the line as the dependent variable y equals beta 0, the intercept plus beta 1, the slope of the line, times x, the independent variable. The beauty of this is that if a linear relationship exists, the equation allows us to estimate the dependent variable for any value of the independent variable within its range. Let's now look at how this works in our example. Here we can see the scatter plot again. The equation of the straight line in its general form expresses vascular age as the intercept plus the slope multiplied by the independent variable, in this case biological age in years. Using analysis software, we can calculate a straight line that best describes this relationship. The software gives us two key numbers, the intercept, which is 5.33, and the slope, which is 0.94. The slope can be interpreted as follows. If biological age increases by 1 year, vascular age increases on average by 0.94 years. We can also have the software draw this line directly onto the scatter plot so we can see at a glance how the values behave on average. This means we can estimate the average vascular age for any biological age between 33 and 59 years. For example, if someone is 45 years old, to find out, we substitute 45 into the equation. Vascular age equals 5.33 plus 0.94 times 45. Calculating this gives 47.63 years. It is important to remember that this estimate is only valid within the range of the data. If we were asked to predict the vascular age of a 65-year-old woman, we could not reliably do so using this equation. Our estimates apply only to biological ages between 33 and 59 years.
So, if I just throw data into a regression, I'll always get a straight line, right?
Careful! We only use linear regression when the scatter plot looks linear and Pearson's correlation confirms it.
Got it. First check the shape, then the numbers.
Exactly. Then regression finds the best fitting line through the points.
And from that line, I can predict vascular age if I know biological age.
Yes, but only within the range of data we actually observed.
Understood. Stay in range, trust the scatter plot, and let the regression do the predicting.
Perfect summary. Well done.